So we've got that, then 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 we've got something like that. Okay. Then of course it's got a member like this, right? Then it's got a member like this. Then it's got a member like this. Then it's got that there. Then it's got that there. Then they've given us some distance here, right?
Yes.
Then they've told us that at this joint there's a force here. There's a force here. There's a force here. Then here they've given us this, right?
Yes.
A pin. Then here they've given us a roller, like that. Then here they've given us 6 kilonewtons. Here they've given us 8 kilonewtons. Here they've given us 2 kilonewtons. Here they've given us 3 meters, 3 meters, 3 meters, 3 meters. Then here they've given us a height which is 3. Then this longer one is 4.5 meters. Then this is A, B, C, D, E, F, G, then that's H. Okay, so on solving truss problems, we said the first thing, step 1. So by definition, we've defined the truss to be members which are in compression or tension. So by definition, we said a truss has got different members. So you can have a member like that, and members have got a pin like a connection. So if this is A, this is B. It's either this member is being put in this direction, or it's moving in that direction. So in this direction, we say it's under compression. And compression, because we're squeezing it in, it's contracting. In simple language, we say it's experiencing a negative force. Then in this other direction, we say it's experiencing tension. And we said since it's elongating, we say this is experiencing a positive. So that's how the members behave. So we need to find the behavior of all the members. Are they in tension or compression? So for this, step 1 we do is you have to draw your FBD. So we said whenever we talk about the FBD, you have to look also at supports. So you need to identify what supports you have. Like for example, at point A, we have this support, which is equivalent to what? A reaction in the Y and a reaction in the X. Then at point E, we have a roller, which is equivalent to what? Just a reaction in the E. So this is what we're going to use to label on our diagram. So drawing the FBD, so the FBD. For such a problem, what is it going to give us? So I'll say this is a page. Okay, I'll call it page 1. Okay, we can draw it even here, it's okay. So page 2. So in page 2, to draw my free body diagram, what I need on my free body diagram is all my reactions. So I'll draw a straight line. I need all my reactions. So I've got point A, right? So at point A, what am I having? I have AY, then I have AX. Then at point E, I've got one reaction, which is what? EY. Then at other points, at point B, I have a force, which is 6 kilonewtons. At point C, I have a force which is 8 kilonewtons. And at point D, I have a force which is 2 kilonewtons. So this is my truss structure. So I can draw the skeleton of it. So here it's giving me something like that. Then I draw that. Then, and if you've noticed, this is enough for you to solve your problem. Why? Because an FBD says all your reactions and all the applied forces. So meaning this straight line will just be enough. So I can just, to make it look more sophisticated, we can just draw its skeleton, something like that. So you've drawn your skeleton. So from here, these are 3 meters, 3 meters, 3 meters, 3 meters. So you need to apply your equations of equilibrium. So we said we apply equations of equilibrium. Why? So that our body should be in a state of equilibrium, meaning it does not move. So meaning whether there are reactions here, the forces, it will still remain in this static position. So to apply that, the first one is you can indicate that this is my what? My x positive, and here I can indicate that this is my what? My y positive. So the first equation we can apply, since it's a 2D problem, is the sum of forces in the x direction, x in this positive equals to 0. What is it going to give me? I check. At this point, do I have anything in the x direction? Yes, I do. It's ax. So I write ax. Do I have any other x at any other point? No, I don't. So what happens is this will be just plus 0 is equals to 0. So it tells me ax is equals to what? 0. So I'm done with ax. Then I apply the sum of forces in the y direction with my y positive being upwards equals to 0. What is it going to give me? I check. Do I have anything in the y direction? Yes, it's what? A, y. Do I have anything in the y direction at this point? Yes, it's what? Negative 6. Here it's negative 8. Here it's negative 2. Here is what? Positive EY, and all this should be in equilibrium, meaning equals to 0. So I'll end up having AY plus EY. These ones will give me negative 16. I take it to the other side, it gives me 16. So I have two unknowns. So I need to find one of the unknowns to replace here and find the other one. So what am I remaining with? We're only remaining with the sum of moments about a point. So sum of moments about a point. So I have to choose that point. So here there's AY and there's AX. So it means that 2 points I can choose, right? I can choose this point or I can choose that other point. Why am I choosing those points? It's because when I choose, for example, point C, I'll end up solving two simultaneous equations. But that will delay me. I need more time. So what I do is the best option you can have is either pick any of these points. So like for example, that side I picked point A. This time I'll pick point E. So if I pick point E, it means this one here to give me a moment of 0. So I only remain with moments at point A and the other point. So if I say the sum of moments at point E equals to 0, what it's going to give me is this point. I come to this point. For organization's sake, what I would advise is draw a straight line like that. Why I'm saying drawing a straight line is because in one of your quiz, you had something like this. You had a hammer and there was a force, F here. And when you had that force, what was happening at a point like here, this was point E, and you had point E had a reference line like that and a reference line like that. Since this is like that, wherever you have this point having its straight lines and meeting with this line action at 90 degrees, you can always find a moment. So that's the idea. That's why I always draw this line, and I also draw this straight line like that. So what happens is that when I have this, which is my line of action, where the force is acting, right? What will happen is I can join my line of action with this other straight line. What does it give me? A 90 degrees. So line of action, I can join it with this other straight line. It gives me 90 degrees. The same applies here to give me a 90. The same applies here to give me a 90. You've seen that for AX, it's not giving a 90, right? So meaning this one is parallel to this line and eventually to give me a moment which will be equals to 0. So what happens here? My sum will give me what? At this point, I have 0. Then here I'll have what? I draw my positive sign sense. I say everything which is going in the anti-clockwise is what? Positive. And everything in the clockwise is what? Negative. So what am I going to have? In this direction, I'm turning in this direction. Which direction? This is the positive direction. So meaning to give me the distance of 3 times 2. Then here to give me what? The distance of what? Plus 6. Then to give me what? 8. Then to give me plus 9. Then to give me what? 6. Then when I come here to give me, this time it's moving the other direction. So it's to give me minus what? Minus 12. Then AY. And all this is equals to what? 0. So this will simply mean AY is equals to what? When we calculate This times this, that's 6, that's 24. So what does it give us when you compute?
50,
Uh-huh.
54 plus.
Then you have to divide by 12, because I know this one is equals to 7, so meaning AY will be equals to 9. So normally it should give you 9 kilonewtons. And since you have your 9, you can inject your 9 here and find your EY. So that's the thing. I need another pen. Yeah, so it gives you 9. Perfect. So now we found all the what? The reactions. Now we can apply our joint method. So to apply your joint method, you draw your diagram. You have that. Then you have that. Then you do that. Then you have that. Then yeah, it extends. It goes there. You have that. Then here you draw what you had. Here we had what? AY was equals to what? 9. Then here AX was equals to what? 0. Then here we had what? Y is equals to what? 7. Then of course here we had what?
6.
At B6. Here we had what? 8. Then here we had what? We had 2. So we have that. Then of course our members are like that, right? I have something like that. I have something like that. So here I even redraw all my members. So I draw them. Yeah, I draw them. So I had A, B, C, D, E, F, G, and H. So I have that. So I found all the reactions, I've labeled them. So joint method, what we're interested in, member, or let's say members AH and AB, are they in tension or in compression? So we said tension is what? A positive force we find in the member, and this side is a negative force we find in the member. So we can start with these two members. So joint method simply means you go where you've got your joint. So where I've got my joint, I go where I've got my joint. So for me, I would advise you just draw roughly something like this until, for example, this is A until B. So you draw A until B, then you draw until H. Then you label, this is how many? 3 meters, right? Then here the distance has been given, right?
Yes, 3.
It's also 3. Then the highest is 4.5. So you also do it's up to 3 meters. Then from there, at this joint, what do you have? You have 9. Then here you have what?
0.
You have a 0. Then from here, at this joint, what happens is that, what's happening is that I can't see really the force. So the force is referred to as an internal force, meaning it's inside the member. It's just like a tension in a rope. So what you do is you actually create what is known as a virtual cut there, and you also cut. So it becomes like more of a cut, and it becomes more of a cut. Or what others would say is, you can forget the cut and just say, yes, okay, it's the same as the cut. So what I'll do is, here at this, up to the cut or after the cut, what I'm experiencing here is the following. So I'll have the following. So what we say is that in each member, suppose a tension. So in each member, so when I get a member like this, I'll suppose that this member, since I've drawn like a cut, there's a cut, I'll suppose that it's experiencing a positive force. So I'll just put N like that. So it's a tension. Even in this one, I'll suppose it's a tension. Then I'll label to say this is AH. Then I'll label to say this is A, NAB. So I'm supposing it's a positive. So what happens is that this force here will be equivalent to the other direction, and will also be equivalent to the other direction. So it will be equivalent to what? B, A, and it also be equivalent to H, A. So these ones, if I find this is the same as I found also the others. So what I do is, I have that, I label this. Then once you label them, of course, it's evident that this is inclined, right? So what you do is, at each and every point, at the point here, you have to label a reference. So I'll label to say, in this direction, I have my Y positive. Then in the other direction, I have my x positive. So why I indicated point B and why I indicated this is because once you have your reference, what does it mean? It means I need to find the projection on this axis. I also need to find the projection of this one, this axis. So meaning you have to calculate the angle theta between this member and that member. So if you want others say A H, then I say A B, then I say this like that. So a hat, it means the angle in between. So my angle in between is what? If you use your, oh, there's a page behind. So this is page what? 3. So if I use my Socator, right? Okay, for better vision just. So my page 4. So if I use my page 4, what is going to happen is, if I use my Socator, what will happen is that this is the opposite by adjacent. So meaning my theta, which is AH, then which is AB, with the hat meaning the angle in between these two members. So this is just simply angle in between the two members. What is going to give me to be what? The tan inverse of what? 3 by 3, which is 1, which will give us 45 degrees. So me, if it gives me 45 degrees, what it simply means is, since I've done my geometry, so I'll just draw a straight line like this, and I'll label this is A, B, and I'll label this is what? A, H. Then here I'll say it's the angle what? 45. Then of course this was my axis of what? X positive, and this was my axis of what? Y positive. So it means that this also here is what? 45 degrees. So it means the projection on this axis, right? It will give me what? NAH of what? This is line on the opposite, so it will be sine of what? 45 degrees. Then on this other axis, because this is a vector, meaning I have to go this direction, then I have to go upwards. So this upwards, the fact that I'm going upwards, it means here in front I'll put a positive. I'm going in this direction, so it means here it will also be positive NAH over cos 45 degrees. Then sine of 45 degrees is equals to what? Is it 1 over square root of 2, which is equals to square root of 2 over 2. So what you do, now this is important. There are certain angles you should know by heart, the special angles. So, because this is square root of 2 divided by 2, it gives you that. So this is equals to 1 over square root of 2, which is equals to square root of 2 over 2. It's the same with the cos 45 degrees is equals to what? It will give you the same. It gives you the same. It gives you square root of 2 over 2, or 1 over square root of 2. So what this simply means is this part here, it will be square root of 2 over 2, and this part is square root of 2 over 2. So when you reach this point, so the joint method, the advantage of joint, it simply means apply the sum and the sum of forces in y and x. Oh no, y is up positive there, then this is that positive equals to 0, and you'll be able to find all your unknowns. So what it will simply mean at this point, I'll say the sum in the x, right? In the x direction, I check this is at joint A. So I found everything at joint A, the forces which are possible. So here to give me what? NAH square root of 2 over 2. Then it will give me plus NAB is equals to what? 0. Then I check, so this will be 2 unknown. So meaning I still need to solve. Then the other thing I almost forgot. At this joint, what did we find? 9. We found 9, and here we found what? 0. So meaning here there's a what? Plus 0, which is equals to 0, so we're settled. Then in the other direction, what do we have? We have NAH square root of 2 by 2 plus what? Plus 9. Then is there anything else? No. Then this is equals to what? 0. So this simply implies NAH is equals to what? Negative 18 by square root of 2, right? Because this goes here, then you multiply 2 times 9. Then what does it give us? The final answer, it gives us what? Negative 12.72 8. If I round it off to 3 decimal places, kilo newtons, right? In brackets, it's negative, right? So what does it mean? It's undergoing what? Compression. So you put compression. Compression. So you put it undergoing compression. Then you replace this answer in this, right? So when I replace it in that, it will imply NAB will be equals to what? If I replace it, okay, if I say negative 18 by square root of 2 times square root of 2 over 2, then yeah, with the negative, so plus NAB equals to 0. So this and this will cancel 1, this will give me 9. So NAB is equals to positive 9. So this will give me 9 kilonewtons, which will give me what? Tension. So that's why I'm saying for special angles, you can see if you can convert them like that. But anyway, in all circumstances, if you don't convert them, just keep them at least to 3 decimal places, then at least it will be very close to the original answer. So this is how you apply the joint method. What time is it? Yeah, we're supposed to finish at 15.
Unfortunately.